Okay, and this is math 2. We're going to do number 10. No, I lied. Number 11 to number 14. On number 11, I would highly recommend graphing both of those to see what they're going to look like. So if you have issues graphing right now, you can give yourself, or I usually like to rewrite these sometimes if it helps. So I have x minus 0, y minus 0 equals 25. And then this one, x plus 9 squared plus y minus 0 squared equals 34. So the center for the first one, right? This is the first one. This is the second one. The center for the first one is going to be at 0, 0. And then your radius is going to be at 5. The second one, your center is going to be at -9, 0. And your radius is going to be at whatever the square root of 34 is. I don't know what that is off the top of my head, but it's probably going to be somewhere like 5.8, 5.7, or somewhere around there. So graph both of these, and you should be able to figure out where they intersect. And then check your solution, use substitution. Okay, I don't know about substitution on this one, but I'm going to show you how to do it using equal values method because that seems a little bit faster in this case. So graph both of these first because you need to actually practice graphing. And then press pause, finish graphing, and then come back, and then I'm going to do equal values method, actually, not substitution, because that seems a little easier. So in the equal values method, and I'm going to cover this up in a second. In the equal values method, what they don't have on here is what I wish they would have done it. You can actually take the first one and rewrite it. So I'm going to subtract the x squared on the first one. I'm going to subtract x squared on the other side. So I have y squared equals 25 minus x squared. Okay. On the second one, I'm going to take this whole thing here and I'm going to subtract it to the other side. So I have y squared equals 34 minus x plus 9 squared. Okay, so minus this whole thing. Now you have the two y's equal to each other, so you can actually put both equations equal to each other now. So in this case, we have 25 minus x squared is equal to 34 minus x plus 9 squared. Okay, and this looks really ugly, but it's okay. It's not that big of a deal. So 34 minus this whole thing in here. So x plus 9 squared is x squared plus 18x plus 81. If you're not sure why, you need to do a box for this if you want to, and do x and 9, x plus 9, and then work it out, and then that should give you this part right here. All right. Now it's minus this whole thing, so everything is going to have to be distributed with a -1, so it's going to be minus x squared minus 18x minus 81, and then you have 25 minus x squared, and if you add x squared to both sides, ooh, wow, this comes out really nice and clean. 25 equals 34 minus 18x minus 81. You should be able to find x by yourself in this case. Okay. Work it out yourself. Find x, combine like terms first, 34 minus 81 first, and then do the work. And then once you find the value of x, plug it back into one of the two equations. My advice is plug it into the one at the top that seems a little easier, and find the value of y. Sound great? Should come out really easily. So that means, since we only have one value of x, that means this circle is only touching at one point. Did we do something wrong? No, it looks okay to me. Put them equal to each other, distribute. No, looks good. Yeah, I guess it's only touching on one point. Okay, all right then. That was 11. And then 12 is multiple choice. Which of the terms below describes x in the diagram at the right? So what you need to do is you need to pick up your book and go to page 433 in your book and look at the math notes from this page 433, and then answer this question. Okay. All right, number 13 is solving. The only ones that you might have some issues with are A and, well, actually, I don't know. You might actually have some more issues than I think you would. You should have no problem with C, so I'm not even going to do that. I'm going to set you up for this one, and then you can I'm going to go to the other two. So part A says solve each equality, rewrite it first in a more useful term. 25 and 125 are not the same base, so I kind of usually want the same base on these. So what I usually do is I say, okay, 25 is 5 squared. So 25 is 5 squared, because that's this 2 right here, is equal to 125, which is 5 to the third times x plus 1. And so now we have 5 to the fourth is equal to 5 times 3 times x plus 1, all up in that little area, in your exponent area. So that means since your bases are the same, your exponents have no choice but to be the same. So you have 3 times x plus 1, and then solve for x, whatever x might be. Okay, and D is kind of the same thing. You just you're working 1/3 a little bit backwards. So 3 is probably going to end up being your base. 9 is the same as 3 squared, and there's the x. 1/3 is the same as 3 to the negative 1, and you have x plus 3, and it's pretty much the same thing here. So you have 3 to the 2x is equal to 3 to the negative 1 times x plus 3, and then we have so we have 2x is equal to negative 1 times x plus 3, and you can solve for x on your own here. And then B is you need common denominators for all of these. So 5, 3, and 1 have 15 in common, if I'm not mistaken, right? So 5, 3, and 1 have a 15 in common. So I'm going to rewrite all of these with 15 as the base. So 5 times 3, so 3 times x. 3 times 5 is going to give me 15, so it's going to be 5 times x minus 1. And then 15 times, well, times 15 times 15, so that's going to give me 30. Okay, so this is times 3 times 3, this is times 5, this whole thing is times 5. That's why it's in parentheses. So since your base is the same, this makes life really easy for you, because now you can just take the denominators, the numerators, and put them all equal to each other and solve for x. Okay? And that's part B, right there. And number 14. Hokiri's ladder has 2 legs that are each 8 feet long. Okay, that makes it convenient. So that means we have an isosceles triangle, right? So this is 8 feet, this is 8 feet. And locked for use, the legs are, when they're locked for use, the legs are 4 feet apart. What is the angle that is formed at the top of the ladder where the legs meet? So we really want this angle up here. So if I know this is an isosceles triangle, which it is, then if I drop a segment down, in this case it's going to end up being my altitude or the height of the triangle. So that means we have 2 and we have 2 here. This is an isosceles triangle, so it's not 60, 60, 60. That would be an equilateral triangle. We don't know what this angle is up here, so we're going to call it x degrees. But if you do find it, you could just theoretically double it up, right, and get the whole thing. So this triangle here, this is 2, this is 8, this is 90, find the value of x. And you need to use inverse trig for this. You should be able to find value of x on your own by now. Okay, so that was the homework. If you have any questions, I'll see you at tutoring.